Address mapping. In previous videos, we have seen how internetworking works. To send a packet from one end to the other end, we must map variety of addresses. In this video, we will learn how to map different addresses for routing. To send a packet from one network to another network, the source needs both logical address and physical address. Sometimes the source device knows IP address, but does not know physical address. And sometimes the source knows physical address, but not logical address. ARP protocol is used to map a logical address to physical address. And, to map physical address to logical address, we have three protocols: RARP, Bootstrap Protocol, and DHCP. ARP, Address Resolution Protocol. Let us consider a host, and a router. If we want to send an IP datagram from this host to router, the host needs to find IP address of the router. It gets the router's IP address from the DNS server. It asks DNS server for the IP address to the given URL. In return, the DNS server sends back the IP address to the host. If the router wants to send an IP datagram to host, the router gets the IP address of the host from its routing table. The IP address is added to the packet at the network layer. And the next layer is the data link layer. The data link layer must add physical address or MAC address of the next device to the packet, to be able to pass through the physical network. That means, the sender requires the physical address of the receiver. Well, then, how does the data link layer know the physical address of the next device? This is where the ARP protocol comes into the picture. The host broadcasts an ARP query packet over the network. The packet includes the logical and physical addresses of the host and the logical address of the receiver. But does not append the physical address of the receiver, because it does not know the physical address of the receiver. Each and every host or router on the network receives the ARP query packet and processes it. But only the intended host or router recognizes its IP address appended to the ARP query packet. Then that device sends back an ARP response packet. It does not broadcast the response packet, it unicasts the packet directly to the host or inquirer by using the physical address received in the query packet. This ARP response packet contains the recipient's logical and physical addresses. Using this ARP is inefficient. If a system needs to broadcast an ARP request, for every IP packet it needs to send to another system. If the first IP packet's ARP response packet is kept in cache memory, it doesn't need to broadcast the ARP request packet, for every IP packet it sends to the same destination. Now, we will see, how come a device get to know about its logical address, if that device knows only physical address. There are some situations that, the host knows only its physical address, but does not know logical address. This may happen when the device is rebooted. When rebooted, it knows its physical address by looking at its interface, which has physical address imprinted on it. And, it does not know its IP address, when a new device is added to the network. We have three protocols for this purpose. They are RARP, Reverse Address Resolution Protocol, BOOTP, Bootstrap Protocol, and DHCP, Dynamic Host Configuration Protocol. We will learn about RARP protocol for now. Reverse Address Resolution Protocol (RARP). This protocol finds the logical address of a device, that knows only its physical address. To find the logical address, a RARP request packet would be broadcasted on the local network. There must be a special host in the local network that knows all the IP addresses. This device is called RARP server. RARP server will send a RARP reply message to the requesting device, which contains the logical address of the device. The requesting device and responding device must be running a RARP client and server programs to get this job done. Subnets, they need to assign a RARP server for each subnet separately. This is definitely not a good solution. That's why this protocol is not useful anymore. We have two other protocols replacing RARP for good results. They are Bootstrap Protocol and DHCP protocol.